Hello, PreCalculus. Here is section 2.4.2. We're working with upper and lower bound tests. We're on U try A, which looks like this guy. So remember, the first thing we kind of want to do here is graph it to get a ballpark figure. Now, I had some people ask me today in class, does that mean we will get a graphing calculator on your test? No. Well, Ms. Harris, how are you supposed to do this without a graphing calculator? I will provide you guys a snippet of what the graph looks like, but it's not going to give you the precise zeros, but it's going to get you in the ballpark so that you can test some pretty accurate upper and lower bounds to reduce the amount of time that you have to spend on it, especially on a quiz. So in other words, you might get something maybe that looks like that, maybe even less precise than that, so that you're really trying to guess what's in there. But did you have an idea that, well, it looks like we're at least maybe -15, maybe even -12, and on the other side probably 1. I would test first. It looks like it's only crossing twice, but we need to check that with an upper and a lower bound test. So we think maybe, what did I say, -12? Forgot already, wow. We thought maybe -12 and 1. So let's test that to be our upper and our lower bound. So -12 and 1, we got 6, 70, -21, 35, -12. All right, if it's a lower bound, what do these guys have to be? Alternating in sign, right? So bring down the 6 times -12 is -72, plus 70 is -2 times -12 is 24. Minus 21 is 3 times -12 is -36, plus 35 is -1 times -12 is 12, and that is a 0. So that's good. That would be my, oh, is it a lower bound though? Is that my lowest 0? We think so from looking at the graph. Checking our signs, positive, negative. It is a 0, and it is going to be our lowest 0. So why did I put a bracket there instead of parentheses? Because it is a 0. All right, testing out 1. We've got 6, 70, -21, 35, -12. Bringing down 6 times 1 is 6. 76 times 1 is 76. Minus 21 would be 55. Times 1 is 55. Plus 35. 5 plus 5 is 10. 8, 9. 90 minus 12 is 78. Well, is that a 0? No. But what is true about them? They're all positive, right? So we know that the highest it could be is 1. But we're not going to include that one. It's going to be parentheses because 1 is not a 0. We just know that our zeros can't be bigger than 1. So looking at our possible zeros, how does that help us? So possible zeros, factors of 12 are 1, 2, 3, 4, 2 times 6, 1 times 12. All of our factors of 6, there's 1, 2, 3, and 6. All right, dividing those guys out, of course everything divided by 1, so 1, 2, 3, 4, 6, and 12. I'm sure you can hear my pen. All right, and we need to divide by 2. So 1 divided by 2 is 1/2. 2 divided by 2 is 1. 3 divided by 2 we need in there. 4 divided by 2 is 2. We've got that. 6 divided by 2 is 3. 12 divided by 2, we have 6 as well. Now we're going to divide it by 3. 1 divided by 3 is 1/3. 2 divided by 3, 2/3. 3 divided by 3 is 1. I do have 4 divided by 3. 6 divided by 3 is 2. We've got that. 12 divided by 3 is 4. Got that. Whew. Finally, 6s. We've got 1 divided by 6. 2 divided by 6 is 1/3. We have that one. 3 divided by 6 is 1/2. We have that one. 4 divided by 6 reduces down to 2/3. We have that one. 6 divided by 6 is 1, 12 divided by 6 is 2. So this is our number. We know then it has to be between negative 12 and 1. Well, negative 12 doesn't really help us much because there's nothing less than negative 12 that were even possible. But this 1 over here does help. So it can't be bigger than 1, and we know 1's not a 0. So this is not it. This is not 1. 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 What else? 3/2 is bigger than 1. 4/3 is bigger than 1. The rest are all possibilities. So at this point, what do you want to do? Let's go back to our graph and see what we think the ballpark is, if we can find them. We thought that it was 1, but it's clearly less than 1, and we got tons of fractions to test there. So let's see if we can, but it looks like we only have 1 negative, so I'm not really worried about all those negative numbers. I'm trying to find that one other 0 that we see in there, so it's going to be 1/2, or 1/3, or 2/3, or 1/6. Seeing that 6 in the leading coefficient, I don't know, I'm going to go with 6. I'm sorry, 1/6. So I got 6, 70. Actually, what can we do? We can actually use, not this one here, because that was a 0. So we're going to use the smaller one. So 6, -2, 3, -1. Bringing down the 6, 6 times 1/6 is 1. -2 plus 1 is -1. Times 1/6 is -1/6. Now it's a little ugly, right? I've got 3 minus 1/6. Common denominator would be 6, so I need to change 3 times 3 times 6, which is 18. Minus 1/6 is 17/6. 17/6 times 1/6 is going to be 17/36. That is not going to be a 0. So not 1/6. We can take that off, and we know it's not negative. Or we think it's not negative anyway. So let's see. What else do you want to try? How about 1/3? See if that gets us anywhere. Bringing down the 6, 6 times 1/3 would be 2. Minus 2 is 0. Times anything is 0. Bring down the 3. 3 times 1/3 is 1. Minus 1 is 0. Yay, we found it without too much trouble. So our zeros then are -12 and 1/3. Why am I done? Well, what do we have left over here? 6x squared plus 3. Can you factor that guy? Well, I can bring out a 3, right? But I'm left with 2x squared plus 1. Are we going to be able to factor that one? No, it's going to end up having an imaginary solution, which we will deal with tomorrow. And when I take the square root, I have a plus or minus an I. So these are the real zeros that we have. These two numbers do live inside this interval that we found earlier. So this is the right interval, and these are the real zeros for part A. Go ahead and write down part B, come back for video 3 and see how it's worked, see if you got it right.